Hey, welcome to N is for Networking. I'm Ethan Banks with Holly Metlitsky, and the format here is I've been doing networking since the 90s, while Holly's been at it for just a few years, and I have scars, and she's getting them. And we talk and compare notes and ask questions and hopefully help you understand hard networking concepts in a simple way. So maybe you're a university student, you're learning networking, or you're in marketing, or you new SE, and you're working for a networking technology vendor. You're working on your JNCIA or a CCNA. This show should help you out. Send your comments, your questions, and your well actuallys, since there's a few of you that are senior networking folks enjoying these fundamental N is for networking episodes, and you got some well actually comments to make. Send all that stuff to packetpushers.net/follow-up. That'll going to help us with errors we make or badly phrased explanations, because sometimes what comes out of our head isn't maybe the best way to put things, and we might lead people astray. Let us know about all that stuff. We don't want to make mistakes, but if we do want to hear about them, so we have an opportunity to fix them at some point. On today's episode, we are going to continue our open, shortest path first OSPF routing protocol discussion, and we're covering the two most fundamental link types that you're liable to run into when working on OSPF networks: point-to-point and broadcast. Point-to-point and broadcast network types. And so I'm cracking up because I think I know what you're going to answer here. Last time we chatted about this, you're like, this has not come up as a thing. You've been studying this stuff and network types haven't been a thing. Are they a thing yet since the last time we recorded?
And link type was mentioned in passing, like this can be done, or it was just like very vaguely mentioned. I was like, I only picked up on it because we've had this discussion and I was looking for it. But no, in short, no. It's just like, this is kind of a link type and we moved on, which is interesting. So I'm excited to get into this discussion.
Okay. Well, okay, so you haven't spent a lot of time on it in whatever study program you're working through right now, which is what you're working on, JNCIP?
JNCIP Enterprise.
Okay. Which is a lot of route switch, and what else is in the JNCIP program?
Just routing and switching. Okay. Everything routing and switching.
Okay. So like OSPF is just one of the routing protocols you have to learn. What else is in that mix?
Yeah. OSPF, BGP, IP multicast. I think there's actually an EVPN VXLAN at the end of it. Yep. I think there's some things in between. There's like 40 different.
That sounds right for the. Yeah, I mean, we didn't even talk about all the switching stuff that could go on there, and everything you talked about there are all building blocks for so many other technologies that they may choose to throw into the mix. So okay, I'm guessing you either heard about link types and it just kind of glossed over. You just kind of didn't like sink into your brain. As it is a necessary thing to understand. Although it's not what it was like 30 years ago when I was first getting into this stuff, because it used to be we had a variety of different link types that OSPF might need to care about. Now, so much of the world is just Ethernet. Even a WAN circuit you get, there's a pretty good chance it's an Ethernet handoff. So things have changed a lot, and we don't have as much of the complexity that we used to have with OSPF, depending on what sort of a network it was connecting to and needed to communicate over. So just backing up a step, and with that context, have you figured out a sense of what OSPF network types are for? What is the point of them? Why do they exist?
Well, I guess it's to understand. Obviously, OSPF is looking for a shortest path. So depending on what link type might change the way the algorithm runs or how certain routers are elected for their purpose in the network. That can change based on the type of network you have or type of link it is. I do actually have a vague memory of me trying to configure something when I just started in like our MIST portal and picking link types. I think it was link types for OSPF because I was dealing with OSPF, but I had no idea what was going on. And I was like, okay, I'm just gonna, this looks like this kind of link. Let's see what happens, with no understanding of it. So I've definitely come across it.
Some of what you said was right, and some of what you said was not. So based on, but I know where you're going with your assumptions. The idea here behind a link type is that OSPF needs to understand what the underlying network medium is that it's plugging into, so that it knows how to find other neighbors. Is really the thing. How is it going to discover other OSPF routers that might be on that link, sharing that link with them so that they can communicate with them? I think that's the biggest thing. That's the biggest concern. With Ethernet, let's just start there. We've got a broadcast medium. We spent several episodes talking about
Hmm.
Ethernet. And do you remember, did we talk about Ethernet before switching, what Ethernet was like?
We might have.
It was a bus, right? Like literally like a long wire, and
Yeah.
everybody would connect to that one wire and then could see each other over that wire. So it was like this shared physical wire that electrical signals would go across to communicate one to another. Again, called a bus. There were in that and that is a common broadcast medium. Station A sends a broadcast out. Who's going to see it? Everyone else that's connected to that bus, right? Now, in switching,
Hmm.
we've changed that a bit so that there's now effectively one wire per workstation that we all connect to, and then there's a switch in the middle that's a gigantic series of bridges that connect all of those wires together, and we have bridging tables now. We learn MAC addresses and try to figure out who is living off of which port in our switch. But fundamentally, Ethernet remains, as it was originally, a one-wire broadcast mechanism. Um, and so from an OSPF perspective, it's not Ethernet savvy, right? It doesn't know that there's Ethernet down
Hmm.
there or there's some other kind of network transport underneath it that its packets are going across. So you got to give it a clue. And the clue here in the case of Ethernet would be, hey, OSPF, you're on a broadcast network type. That is, if you want to discover other OSPF neighbors, you can put a multicast packet on the wire, 224.0.0.5, send your hello packet out on the wire, and anyone else that's on the wire, and anyone else, any other OSPF routers, because that's who 224.0.0.5 is addressed to, will hear that and then go, oh, hey, and then return a hello packet. And it goes back through what we talked about an episode or so ago about how neighbors are formed, the hello exchange and all of that goes. If it wasn't Ethernet, if it wasn't a broadcast medium, we might do something else. We might handle the situation somewhat differently. All right, how are we doing so far?
Yeah, I think my thinking where kind of went a little bit haywire is I'm conflating network types and then link
Yep.
types. I think because I don't think I think about link types when it comes to OSPF. You know, like you mentioning what's actually being transported. And is it
Mm-hmm.
Ethernet? And my assumption, obviously, it's Ethernet. What else? What else would we have? Um,
Okay. Yeah. So this is where the history comes in. So back in the day, if I
yeah.
was ordering a WAN circuit, a wide area network circuit of some kind, I didn't know exactly what the carrier was going to hand me. It probably wasn't Ethernet 30 years ago. It was something else, some kind of a serial line, like we've talked about TDM briefly, time domain multiplexing
Hmm.
style of a circuit. That's not Ethernet. That's a different way to encode packets electrically and send them across the wire. Not a broadcast medium. So they might hand me some kind of like a T1 circuit, let's say, 1.544 megabits per second, and not Ethernet, going to be serial framing of some kind. Maybe it's PPP, point to point protocol, or maybe it's HDLC, which stands for something. I didn't look it up. I forgot. I used to know. and, and those sorts of transports, again, not Ethernet, are not broadcast medium. And so in that case, you would tell OSPF,
Hmm.
hey, your network type here, that is point to point. That is a point to point link. And when we say point to point, that does imply something. There's not 15 different routers hanging off this segment. There's two of you, one on one end and one on the other, and then you got a line
Hmm.
between you. And so you got the hello discovery process can be handled somewhat differently. In the case of a broadcast meter, we talked about this last week. We talked about Ethernet. When there's the hello packets that go back and forth, and there's another election process that goes on that broadcast medium. What was that?
The when you are deciding who's like your
Yeah,
designated router,
yeah,
that kind of
exactly.
yeah.
You're going to
Okay.
assign on your
Yeah.
broadcast medium. There's going to be a DR, a designated router, and a BDR, a backup designated
Hmm.
router. Well, that's because you've got a whole bunch of different routers potentially that are connected on that broadcast segment. and you don't want everybody to exchange their full link state database with everybody else as a full mesh. You're asking everybody to do a lot of calculations. And so you designate a router that's going to be the point person, the router that everybody goes to get to share their link state updates and to get their link state updates from, and to do that synchronization job. And then because it's such an important role, you have a backup designated router. So if the DR falls off the wire, the BDR takes over immediately and then begins fulfilling that role. Okay. Do I need that on a point-to-point link? No.
No, because if you're point-to-point, you've got a backup and a designated router. And if one falls off, well, what is that designated router speaking to? Because you only had
That's right.
two.
So there's no. So you have no. So in a point-to-point network type on OSPF, you have no DR/BDR election process. You just got two routers talking to each other. That's it. Because if the other one falls off, because the circuit goes down, whatever, there's no one to talk to anyway. So why would we go through the DR/BDR election process and all of that? And honestly, that is the chief difference between point-to-point and broadcast. With a broadcast OSPF network type, you're doing your same hello process, 224.0.0.5. Hey, everybody, I'm this router. Hey, I see that. I see you. And then responses and so on. And then an election of DR and BDR. Point-to-point, there's still a 224.0.0.5 multicast packet that goes out on the wire, but there's no DR/BDR election process, because why would you? So the discovery process is the same. No DR/BDR election process that happens. So okay, so now I'm gonna twist your brain in a knot, or I'm gonna try. You can't use the Friday excuse. It's not Friday. It's only Wednesday.
It's technically a Friday for me because I don't have work tomorrow. It's Juneteenth tomorrow while we're recording. Okay. So
well, all right.
Friday adjacent.
Friday adjacent. What happens if I have mismatched network types? What if I'm broadcast link on one side and point-to-point, broadcast network type on the one side and point-to-point on the other side? Is that is what's going to happen? What's going to happen? Are we going to have an OSPF adjacency? Will it form? Will we have neighbors? Will we exchange link state database? What's going to happen?
It's a great question. I'd love to know. Well, let me think through it a little bit. So, I mean, if you've got point-to-point on the one side, I don't know exactly what steps are skipped. I'm assuming it's whatever the designated router steps are. But if you've got the broadcast, I mean, it's still going to send out the same 224 multicast address. Is going to try and do the same thing. I would just assume that the point-to-point link is not going to participate or respond to the steps that are required for the DR designated router election process.
Yeah, exactly. So you'll end up with this weird cycle where it looks like the OSPF adjacency is forming, and then it fails because you got one side that's totally expecting a DR/BDR election, that the other side's like, I'm not participating in that. I don't care. And then the neighbor relationship fails, and it all. But then they see their hellos again, and they start all over because they're very excited, and then it just goes around in a circle. I think I'm going to do a lab on that actually.
Yeah, I was going to say, because if I think about this, what we discussed the steps of neighbor formation in the previous episode. That step would get stuck in one of those steps and start again. Because it would see a neighbor, it would receive the hellos, so I would assume it'd get to like the two-way process and then fail because now it can't exchange anything else.
Yeah, without doing the lab, I'd have to figure out because we never get to full. We're never going to actually exchange.
Yeah.
So I would think you're right. It would go up to two-way and then get stuck because one side's like, okay, let's elect a DR/BDR, and the other one's totally not expecting that. So it'd be like, I'm ready to exchange databases. Wait, I'm not. And I would assume that fails at the two-way state. But I don't know. It sounds like a good lab to do. Throw up a couple of routers, purposely misconfigure them, and then turn on logging to see how the two routers behave. See if we just turn on OSPF logging and monitor the states that the two routers go through as they discover one another. So I know it won't work. But it'll tease you. Like, I'm kind of going to work. All right, so we've got these two broadcasts. We've got these two network types, broadcast and point to point. Um, there's a scenario. There's a open question of, do we have to actually configure these? Do we actually need to, as network engineers on our routers, configure the OSPF network types? Now, you, having not even seen OSPF network types pop up very often, are going to guess no, I'm guessing.
I looked into it because I've configured OSPF in the CLI, and I don't think I've ever had to specify the link type, but you can.
Mm-hmm.
I think you can, and you can override it. Mm-hmm. But from what I understand, usually it's kind of an automated process. The router sees what it's connected to, and if it's point to point, it's going to know. If there's multiple connections, it's going to know it's broadcast. So you don't have to configure it, but there might be situations where you want to manually override whatever's auto-elected.
Yeah. I completely agree with you. That's exactly it. You don't have to configure it. There is going to be an auto detection. If it is an Ethernet link that is detected, OSPF should be informed by the network operating system. Treat this as a broadcast link. When might that specific scenario have a problem? That is, Ethernet is detected, and so a broadcast link is set up. When might that be? I don't know if a problem is kind of a strong word, but can you imagine a scenario where you might want to override, I guess?
So this came up in my training, actually. The only time that this came up was, I don't think we've discussed areas in depth, but when connecting to OSPF areas or connecting to backbones with different companies, there was a whole section on it. But in short, when connecting areas, it's going to assume that that's a broadcast link, but you're going to want it to be point to point. And that was the only situation that was mentioned where you might want to override that.
Yeah, okay. So that's an interesting specific use case. I mean, that's the scenario that was popping
Very
into
specific.
my mind. But more broadly, it's like, so if you've got a WAN link that functions as a point to point, that is, there's only two routers involved on either side of what is an Ethernet handoff given to you by your service provider, and you don't need to have DRs and BDRs, you could manually override the OSPF auto detection component and say, no, I want you to act like a point to point because we don't need DR, BDR in this scenario. But if you don't, it's going to be fine. You're still just going to have a DR and a BDR election process that goes through, which adds a little overhead. And, they're there as DDRs and BDRs, but functionally, nothing's different about how OSPF is going to work. And something you had said several minutes ago, like, well, maybe how it does path computation is different. Nah, that's not going to matter based on network type. It's still, OSPF's always going to do SPF the same way. It's always going to do the math the same way. Network type won't have any bearing on that. And so you could have Ethernet broadcast with a WAN circuit that's truly just Ethernet handoff on both ends. So it functionally is a point to point, but you treat it as a broadcast. So there's still a DR and a BDR election, and it'll be fine. It's going to work okay. Or you could say, why bother with the DR BDR thing? I'm going to override this and just have it function a little more cleanly. And as network engineers who love to control things and be very specific in how our routers behave, we like to really control that, all the details. Then you set your network type to point on that Ethernet link and skip the DR BDR election process. The only time it's going to be a problem again is that if you have the network types mismatched on either end of the link, now you've got a problem. OSPF's not going to come up. Okay, Holly, so this is going to be a little bit of a departure from the network type thing, but it's something I wanted to bring up because I don't think we got into it in the last episode when we were talking about DR and BDR and all that stuff. When you elect a designated router and a backup designated router, first of all, there's a process to that election. So I want to discuss how a DR and a BDR are chosen, and then what happens when we have a failure? What happens when a DR goes down, and so on. So do you know when you've got a bunch of routers on a network segment that are all OSPF routers that are communicating with each other, how do they elect who's going to be the designated router?
So the easy way is your super controlling network engineer specifies. but we don't have to do that. The other way is there's a bunch of, yes?
Well, you said specify. I mean, how would I specify that as a super
Yeah.
controlling network engineer?
So there's a bunch of metrics if you haven't specified that OSPF will go through to see who's going to be picked. And the first thing that it looks at is there's a priority metric.
Yep.
And you can specify that priority metric to be something that's very specific, so that I think it's the highest one highest wins.
It's the highest OSPF interface priority number wins.
Yeah.
I want to say it's a number between 0 and 255, but I didn't actually look that up. But that rings a bell.
That sounds right. Yes.
Yeah. Okay.
So you can set that to 255 if you want that to be, you want that to win, or you can let OSPF figure out and go through all the routers and see which one is the highest priority.
Now, if we had not done our super controlling network engineer thing and set a priority to any of the interfaces, then every interface is going to have the same priority and they'll all be tied. What's the tiebreaker? So
then we go to router ID, which an OSPF router ID is usually the loopback address of that router is set to the router ID, and the highest one of that will win.
Yeah, loopback address will be auto-selected for the router ID of that router. The highest loopback address will be selected as the router ID. Or again, super controlling network engineer, you can set your router ID manually to whatever you want it to be. It'll be in dotted quad format. It's going to look like an IP address, but you can set it to whatever you want. The router ID it's truly an arbitrary number. The only qualifier for a RID, a router ID in OSPF, is it's got to be unique. You can't have the same RID on two OSPF routers or bad things happen, Holly. Ask me how I know. That you will have complaints from your OSPF network. It's like, hey, I'm seeing link state updates coming from somebody that isn't me, but they've got my router ID. And I'm really upset about that because all of a sudden the router ID is part of how the OSPF calculation works. It's how you know who you are and what perspective you're coming from and who everybody else is. That router ID is a big part of this. So if you have two routers in your OSPF network with the same router ID, it's bad. It's really bad. So you don't want to do that. And you will get many complaints from your OSPF routers about that duplicate router ID having been detected. Okay, so we're back to the designated router, backup designated router election process. Highest OSPF interface priority wins, which you can set. If you didn't set it, so everybody's tied, the highest OSPF router ID wins, and the router ID will have been, if you didn't set that, will have been auto-selected to be the highest loopback interface. And if there's no loopback interface, I think it's the highest number IP address on the router. I think is what it'll pick.
Yeah,
there is a process.
It's the highest link, the IP on one of the links.
Yeah, physical address assigned.
Yes.
Address assigned to one of the physical links. Yeah. Okay, so we're gonna. These are our conditions that the OSPF process will use to elect a designated router, and then you'll have someone in second place that becomes the backup designated router. So here's the next question then. We're going along, OSPF's fine, we've got our elected DRs and BDRs all doing their thing, and then the DR has a bad day and he falls off the wire. Circuit blows up, he crashes, whatever. Now what happens?
Well, now, luckily you have a BDR. And your backup designated router now becomes your designated router. And I would assume that now you're going to re-elect a new backup because your backups become a designated router. Is that correct? You've got to do that.
You need another BDR, yeah. You want someone else on the wire to take over, assuming there's anybody left. But yeah. You would have another election for a new BDR to take over. So now the old BDR has become the DR, and the BDR is an unfulfilled role. So we have an election to figure out who the BDR is going to be. Now there's a new BDR. Okay, and now the DR that blew up gets better, and it's back. Does it take back over as designated router?
It does not.
It does not. You are correct. It does not. You're looking at my notes? You're looking at my notes, aren't you? I can see, see what you're doing.
I mean, I know that anyways. Because why would you? Like, if you think about it logically, you've got somebody performing the function. It's a designated router. It's organizing everything. Why would somebody else come back and now it's like, oh, I'm going to look at what your interface priority is. I'm going to like, I'm not going to look at that because the process is already done. We operating as a OSPF routing network now. There's nothing to trigger that.
And so why would we interrupt the communication flow, the exchange of link state database information, LSUs, and all the rest by saying, oh, the old DR is back. We should put that one back in control again. Yeah, exactly. Why? Why would we do that? Just keep everything smooth, keep everything flowing.
It wouldn't know that it's in there like the old DR. It would just see it as another router coming back onto the network.
Right, you'd have to have something happen like, oh, a new OSPF router on our segment has been introduced. We need to have that needs to trigger an election. That would be like an event that would trigger an election, but it doesn't. It doesn't trigger an election event. There is no, the word is preemption. You're not going to preempt an existing designated router just because someone else comes on the wire. Now, back in the day, the reason that you would be a super controlling network engineer and define you'd probably use priority to determine who on your who in your network segment was going to be the designated router. The question is, what would the reason be for that? Why would you want to do that?
Well, if you think about it, your designated router probably has the most computational heavy job. It's got to maintain your link state database. It's got to maintain all the adjacencies. So it's doing most of the work. So if you have any limitations with hardware, or you've got one specific router that's maybe a little bit better, a little bit faster, it's got more space than the rest, you'd maybe want to specify that that's going to be your DR so that it can take on that load.
Exactly. And back in the day, especially, again, we go back 30 years or whatever, that mattered a lot. Like I did a lot of Cisco WAN work, again, back in the day. And depending on the series of router that you had, they were classified for different purposes, for sure. And one of the reasons was the ability of the control plane in that box to handle this kind of work. So you would think like, okay, if I've got a 36 or 3700 series router that's sitting on the segment, everybody else is a 1000 or 2000 series router, which were smaller routers that had lesser capabilities on board. I'm probably going to pick the 3600 series router to be my DR in that segment because it's the biggest, baddest one that's there. These days, I don't know that that's that big a deal. I would, because I'm a super controlling network engineer, like most of us are, we all have certain personality types, right? I would tend to control it just because that's who I am. Is it strictly necessary? Yeah, I don't know. I mean, CPUs have come so far, and the OSPF load hasn't really changed much over the years, unless you've got like a network of huge size with a lot of churn. Do you know what I mean by churn?
Yes.
Yes. That was a question. That was not an answer.
I mean, I'm guessing if you've got a lot of churn, it's you changing things constantly. So maybe you're bringing new routers in, you're taking routers out. There's churn.
Or it's a service provider network with lots of network instability, circuits going up and down, maybe, things like that. But yeah, churn implies there's a lot of things changing in your network all the time. So in the case of OSPF, that would imply a lot of link state updates. This route is been added. This route's being withdrawn. I don't have this anymore. This router's online. This router's gone. If you're constantly doing math and having to run SPF all the time, then maybe that kind of a choice could matter. But I mean, I think the vast majority of networks are just not. You don't have tons and tons of churn in most networks. They're pretty stable overall. So, and then again, modern CPUs, even cheap ones and cheap routers, are going to be a lot more powerful than they would have been a long time ago. So is it that big a deal to like, I got to control who my DR is, and if I don't do it right, bad things are going to happen? Probably not. Probably not. You can leave
even
a
if
lot
you
of
feel
things
that
by
way.
default.
Yeah.
If you feel that way, that's okay. That's not, I mean, honestly, it's part of what makes us good at our jobs as network engineers, is the super controlling aspect of it. It can, okay, so let's
Since I make you good at it, can make you good at your job, but it also can make you bad at your job, because then you have controlled the entire network and it relies on you solely. Not so good.
That's an aspect of it. And then since you have a customer facing job, I want to see, you're the super controlling network engineer, you're the SE working on a customer project, and you want to do the thing and they don't either get it
No.
or whatever. And then you in the customer facing role, how do you handle that?
I have that situation at the moment, where we, as the SEs, we've got a team and we're like, this is how things should be done. And the customer's like, well, I'm going to do it like this. Like, okay, here's what we recommend. Here's a validated design. Here's how everybody else does it. Cool. Thanks for the information. I'm going to do it my way. What do? I say, well, good luck.
Yeah. What can you do?
Like I've given you everything at my disposal, and if you want to do it your way, if it works, fantastic. If it doesn't, well, we try to guide you in a different direction, and there's not much. It will be my problem anyways.
So I'll say that. So we're gonna evolve the conversation slightly towards the business skills side of things a little bit, since this comes up. We as network engineers who love this stuff do tend to have that controlling personality where we really love details. We really love to know exactly how things are and how they work and why they work a certain way, and then control that so that we are in control of our own destinies, if you will, as much as we can, to make sure that the network is going to behave the way we intend for it to behave, and that there's going to be no surprises. I don't want to get called at 2 a.m. We're going to control stuff. And then for me, the challenge was, especially earlier in my career, I'm sitting around a big conference table with 12 people and someone else on the screen from wherever, and then the conference mic thing sitting there, and we're all talking about the big project. And in my head, I'm just going through all these details about, well, if they're going to do that, then we really need to do this. And we should probably order that. Oh man, we definitely are going to need a firewall in this spot. And I'm going doing all these mental gymnastics in my head. I haven't even said a word. No one knows. All this stuff is like going through my brain. And then a question comes up, or somebody says something and my brain goes, stupid, that was stupid. Stop saying words now. You don't know what you're talking about. Please stop. And the words tumble out. They come out of my mouth and I say something that's not quite that rude, but it's like, and then there's that can get you in trouble, especially as a younger network engineer, if you haven't figured out your business skills yet, where you need to learn how to be diplomatic, and you need to learn, maybe this conference room with all these people on the call, including my boss's boss and his boss, maybe I can wait till later to have that part of the conversation. Or maybe it's not as important as I think it is, and I'm just me and I'm all wound up because I'm caught up in the details and it's who I am. And maybe that's not a thing.
Or you just ping somebody on the side and say, hey, can you say this in the meeting, because you know that they're the architect that's been brought in, and take the fall. I'm not going to tell them that everything they're doing is wrong, but you can, because you're the guy who they think knows things.
Make friends. That's called office politics on some level. Figure out who has the sway in the room. If you don't have the sway in the room because you're too new, or you've blown up a few times and people are like, I don't know about that one. That person. Yeah, that's a thing. Those are skills that are unfortunately necessary. I know the idealized version of Ethan, especially when I was in my 20s. I'm in my 50s now, but when I was in my 20s, it was like, well, this is the right way to do it. We wouldn't do it the wrong way, would we? Of course, we're only going to do it the right way, and that means you got to buy these switches and these routers and this other stuff and wire it like this and do it like that. Ethan, we don't have the budget for that. Not even close. In fact, we don't have the budget for really anything. If we have to, maybe we can buy something, but I mean, we were kind of hoping to do this on what we already got. And then my brain, explosion and upset. And why don't they want to do it right? This is stupid. I don't want to work here with a company that doesn't want to do things right. When it's just, that's a very childish way to look at it, but that's the way I felt a lot of times.
Yeah.
Because practically speaking, a business they're limited by money. They're limited by budgets. They don't have infinite money. And to design the perfect network or the perfect IT project, what it is, it always takes infinite money.
Mm-hmm.
And so you're always bounded by budget. You're always constrained by how much money is available. And you're not the only one in the networking component that
Yeah.
is needing money. There's the server people and the storage people and the security people and the cloud people. Everybody needs money for this piece of it. And you're just fighting and clawing for your piece of it. And in many cases, making do with what you got. And that's okay. It's actually fine.
Yeah. And sometimes you have an Ethan on the other side who's thinking, oh, I'm working with this vendor and they know nothing. And you sitting there thinking, well, they know nothing. And it's a fun game to play. I mean, sometimes the situation that I've run into is this customer wants everything to be standardized. So whether it's the correct choice doesn't matter because they've standardized on it, whether it's optics or switches or whatever it is. They have decided this is the standard, this is what they're going to do. Mm-hmm. And we all sitting there like screw your standards, this doesn't make sense. Like
your standards suck. No.
Yeah, like you can't just standardize on like one optic for an entire network and call it a day.
Right?
Like that's why they multiple.
But
it's the standards. So we sit there and we nod and we'll send you your standardized things, and you have a little side chat with your people, and complain about all these things, and then you smile and nod and say, sure, like you whatever you want, and. There's budget, there's personalities, there's 101 different things constraining your perfect network.
Another thing I got over the years, you mentioned having some hothead like me that you're trying to sell to, and me being sitting there with my arms crossed, skeptical, in the conference room while you, the vendor, do some sort of a presentation or whatever. And I learned over the years the vendors were my friends, that I would find the engineer within the vendor org that could answer my questions, or I'd be like, hey, so I'm looking at this switch and this other switch, and one's like way pricier, but I don't think I need it. Can we talk through this? And be like, oh yeah, let's dive in. Let's figure it out. And then have that conversation with Holly was so helpful when I'd go into it initially just super skeptical. Like they're just going to try to sell me everything and a bunch of crap I don't need, and bamboozle my boss into whatever, and I just or they don't seem to know much of anything, what is going on here. But again, over time I found out, man, if you can get connected to someone who works at a vendor that knows what's going on, and can not only, and if they don't have the answer, if Holly doesn't have the answer, Holly knows people and can go find someone within, in your case, the Juniper organization that has the answer and get them to talk to me. Gold, absolutely gold. And when I figured that out, it was like, I felt like it was like achievement unlocked. That was like a big deal to begin to have access to people that were deeply knowledgeable about things, able to answer questions I didn't know I should have been asking. That's humbling. You're like, oh, I didn't even know that was a thing. And they're like, yeah, that's a thing. Yep. Okay.
I work with a couple of those people, and I get on calls and I'm just blown away by their like vast knowledge of everything, like things you wouldn't even think of. And they're like, yeah, you just do this. I'm like, didn't cross my mind, but cool. And I think it's also,
oh yeah,
you've got all these people, sure, they work for vendors, but like deep down, everybody's just like a little nerdy network engineer who's very passionate about, making things work and making things right. So outside of whatever you're trying to sell or whatever the product is, to find those right people to have intellectual conversations with just about your network, whether it's, aside from the vendor chats, it's so amazing just to find those people, and you'll learn so much. So it's, the vendors aren't always trying to sell you stuff, and they can give you a lot of insights. You just got to find those people and build those relationships.
No, I've actually found the opposite. I mean, vendors, I mean, you, I assume in your SE role, you got some kind of a quarterly number hanging over your head. Yep. That's part of being in a sales organization. But I've almost never found someone that wanted to sell something purely to make their number. It was always about, well, I don't want to sell somebody something they don't need, because then they're going to figure out they didn't need it and they spent all this money, and they're not going to come to me the next time they got a network refresh because I broke trust. I want to build trust and build a long-term relationship with my client. And so I'm going to sell them the thing that they need. And, there it is. There we go.
And nothing's worse than selling a bunch of stuff and hearing 6 months, a year later that it's still sitting in the box.
Oh,
It
yeah.
happens.
Yep.
And as an SE, it's my worst thing. And like,
Mhm.
sure, so I hit my number, I sold some things, I made some money. I don't care. I want you to unbox the equipment. I want you to rack and stack it. I want you to play around with it. I want you to come back and tell me how great your experience was. But to hear you haven't even unboxed it, oh, just like stab me and like twist it around. It's terrible.
I'm laughing because I actually have that project right now. I bought some gear in December. It's June right now, and because of snow and winter, and it's a roof mounted wireless bridge,
Mm.
I just haven't gotten back to it. So now I feel bad because I'm that guy right now, Holly.
I'll check in. I'll send you a calendar invite. Have you unboxed yet?
It's going to be July. I already tell you, it's going to be July because I don't want to. I'm going to take a little vacation time coming up here in the beginning of July, and I don't want to install this wireless bridge 2 weeks before I disappear in the woods for a while for vacation. And that's what I do. I go hiking, and then find out the wireless bridge has got some kind of a problem because of an antenna mount issue. Or I don't know what. I want to be right there so I can go support them if their bridge goes down because it'll be a critical link once it goes live for them. Anyway, all right. So long conversation about OSPF network types, at least two of them broadcasted point to point, that morphed into a conversation about there are awesome people that work for vendors. And I've definitely learned that in this job too, Holly, meeting people for well over a decade now, coming up on 2 decades of the smartest, most incredible people work at the vendors. Nah, they're just there to sell you things. Nah, they make the things that make the internet and all the connectivity we have in the world work. They all work for vendors because that's how things get done. We're all consumers. If we don't work for a vendor, we're consuming stuff. So if you don't have respect for a vendor because they sell things and somehow that's bad, you're totally missing the point. You don't understand how technology gets built. The awesome humans that work for vendors. You just got to find them and have conversations, and they've had the opportunity to go deep on one thing, whereas people like me are more generalists. I've had to go not super deep, but on a zillion things. And so I'm never going to be as good at that one thing as that one person working at that vendor who's built their career on it. Is because they've had nothing they've had to do other than dive into that one thing and become super detailed and nerdy about it and write books and whatever else they've done. So it's just finding the right resource.
Exactly.
Well, all right, let's close off the show for today. Thank you very much for listening to N is for Networking. Send us your comments you love and your actuallys to packetpushers.net/follow-up, or you could join the Packet Pushers Community Slack group at packetpushers.net/community and tell us in the N is for Networking pod channel anything you want to tell us. We get lots of feedback from you all. We love it. We really appreciate it. Send more. Do all the things. Would you like, subscribe, tell your friends. N is for Networking is climbing the ranks of the many Packet Pushers podcast series. There's a dozen in the Packet Pushers catalog right now. We got 2 more coming before the end of 2025. Holly and I want this show to be number 1 eventually. So help us out by letting the world know about N is for Networking. We are everywhere you get your podcasts, including YouTube, where you can see Holly and me chatting with each other if you would like. And until next week, just remember, networking isn't hard. Other people figured it out, so you can too.